Thomas, did you have any questions from yesterday's assignment? Numero uno? I don't believe I signed numero uno. Yeah. Number what? 7. All right, number 7. Yeah, great question. So we're starting with cosine 2x equals sine of x. Here's how I know which one to use. I already have a sine function in the problem that I can't change. So that means I want to get this into something with only a sine function in it. So I'm going to make this 1 minus 2 sine squared x. Waiting. Is it 1 minus 2 sine squared x? I don't know. Is it? It is? Okay. Cole was right. Braden's wrong. Is it like Friday the 13th or something, or a full moon, or? Okay. All right. So what I'm going to do now is I'm going to get all this stuff on the same side together, and then I'm going to solve it all on the left or on the right? On the left. All right. So I'm going to put it in order. So I'm going to put the squared first. So I'm going to go negative 2 sine squared x. I'm going to subtract this one over negative sine x. Add 1 equals 0. Okay? However, as I'm sure you're all aware, factoring is hard enough already. It's much worse when you have a negative in front. So I'm going to multiply both sides by negative 1, which allows me to rewrite this as positive 2 sine squared x plus sine x minus 1 equals 0. Okay? Yeah, that's fine. It'll work out to be the same. All right, now I'm going to factor. So if I want two things in the front of each of these parentheses that multiply together to be 2 sine squared, what do they have to be? 2 sine and sine. And then I know I want the things in the end to multiply together to be 1. The only thing that can be is a 1 and a 1. So the only thing I have to figure out now is what the signs, SIGNs, of the 1's are. Plus, minus, or minus, plus? Minus, plus. And the reason it's minus plus is because if I go 2 sine x times 1, that gives me positive 2 sine x. If I go negative 1 times sine x, that gives me negative sine x, and together those would combine to be sine of x, okay? All right, so those two things multiply together to equal 0, which means that they equal 0 independently. So sine of x equals 1/2, or sine of x equals negative 1. So you just look on your circle chart for where the y-coordinates are either 1/2 or negative 1. And those are all your answers. Where does sine of x equal 1/2? Pi over 6 and 5 pi over 6. And it equals negative 1 at 3 pi over 2. Okay. Thomas, how's that? We have a little better understanding now, maybe? Yeah, the test was basically the same thing as this, except for when you factored it, you had 2 sine squared minus 1 equals 0. So then you have to also square root this, which makes it plus or minus root 2 over 2, and then you find those y-coordinates. Okay? Okay. No, you were, looked like you were, I don't know, reading the problem. Ben Wills, questions? Number 9. All right, number 9. Okay. What does sine of 2x change into? 2 sine x cosine x. And that's our only choice, right? What does tangent change into? sine over cosine. No, we're just using this right here. Okay. Okay, so I'm going to get a common denominator, I guess? Or should I just multiply everything by cosine to get rid of that cosine on the bottom? Yes? Okay. So if I multiply this term by cosine, I get 2 sine x cosine squared of x. If I multiply this by cosine, the cosine cancels and I have 0. Okay. What can I factor? Sine of x. So sine of x times 2, whoops, cosine squared x minus 1 equals 0. Okay? Because I just took out the sine. Nope, it's minus 1 because if I am factoring, what I'm doing is I'm dividing everything by sine of x. So if I divide this by sine of x, those cancel and leave me with 2 cosine squared. If I divide this by sine of x, sine x divided by sine of x is 1. I need this to be so that if I distribute this sine of x, I get back where I started again. And if this 1 isn't here, that's not going to happen. Okay? I'm sorry, what? Does it equal sine of 2x, you mean? It might, but we don't care about that. We're going to just go from here. Okay? But yeah, I think that's one of the identities. Okay, so that means that sine of x could equal 0, or 2 cosine squared x minus 1 equals 0. Okay? Right, so this happens with, what, 0 and pi? And then this one I have to add 1, divide by 2, and square root it. So that means I'm looking for where the cosine is equal to plus or minus the square root of 2 over 2. And where does that happen? Many places, yeah, all of the 45-degree angles. Pi over 4, 3 pi over 4, 5 pi over 4. Okay? So that one is rough. It would be, except they want, yeah, the interval that they want the solutions on does not include 2 pi. But yeah, you're right. Okay? Are you crying? Ben? Do you love that? Sure. Okay. Thanks for that enthusiasm. I can, yeah. Cole, get ready. Yes. Okay. 7 pi over 4. All right. So we got to change that cosine 2x into something, right? Yeah, I think so. Yeah. Is that what it was, Shelby? 2 cosine squared x minus 1? Okay, yeah, so you're right. Okay, yeah, so it's going to be a little bit easier if we can get everybody in terms of cosine. So let's try this. 2 minus, 2 cosine squared x minus 1. Okay. All right, so I'm going to bring everything, which side do you want to put it on, the left or the right? The right? Okay. So if I subtract a cosine squared from 2 cosine squared, that leaves me a cosine squared. If I subtract a cosine from nothing, that gives me cosine x minus 1 equals 0. Ruh-roh. I don't think that's going to factor. So you guys are all diligently writing this down, but sadly I don't think this is the direction we want to go. Let's try another one, shall we? What is another thing that cosine 2x equals? Okay, so that would get the cosine squared to cancel, and then we'd be left with cosine x equals negative sine squared x. Can't factor that. I don't like that very much. And the other one is... Huh. I don't like that either. Alright, well, I'm going to stick with this one that you guys all just erased. You're welcome. Okay, nice job. This is a little crazy, but yeah, here we go. Fasten your seatbelts. We're going to use the quadratic formula, okay? But we're not solving for x, we're solving for cosine of x. Because it's not x squared minus x minus 1, it's cosine squared x minus cosine x minus 1. Yeah. So opposite of b is, so in this case a is 1, b is negative 1, and c is negative 1. So opposite of b is 1, plus or minus the square root of b squared minus 4 times a times c, all divided by 2a. I don't like this one bit, because we're going to get a square root of 5 in there. Well, that's what cosine of x equals. I need to figure out what x equals. And that's not on a circle chart anywhere. So this tells us that the cosine of x equals either 1 plus the square root of 5 over 2, or the cosine of x equals 1 minus the square root of 5 over 2, right? You guys know how to get rid of cosine? We did this maybe last chapter. How do I... This is going to be a calculator problem is what's happening here. To get rid of the cosine, I have to do the inverse cosine. Okay? So I'm going to go x equals the inverse cosine of 1 plus root 5 over 2. So on calculator, that means I'm just going to go the inverse cosine 1 plus square root of 5, what row? Let's see. Divided by 2, right? No one's listening to these recordings. Cole, come on. Actually, I was going to stop doing this, and then I looked back at my history, and there were a couple people that... Wait. Oh yeah, what about minus, huh? There we go. Did I do that? Did I type them wrong? No. Okay. So 2.237. Let's see, the book says, yeah, 2.237 and then also 4.046, which you get by, do you want to know where the other one comes from? You don't want to know where the other one comes from? Okay. No, I know how they got the other one. 2.237, remember we're finding an angle, is this right here. So there's also going to be one here that would work. Yeah, so you have to go inverse cosine and then parentheses, 1 minus the square root of 5. 1 minus the square root of 5. And then divided by, and then close the parentheses when you do 1 minus square root of 5. And then divide by 2 and then close the other parentheses. Because you are in degrees. Okay. All right, well, that was really gross. 2.237. Addison, questions? No? Glory, questions? Evan, question? 8? Okay, what do you want to use for cosine 2x? To try the cosine thing again? Worked so well last time. Yeah, so let's go 2 cosine squared x minus 1 equals cosine x. How do you like that? In the middle, if I FOIL this out, first times first, 2 cosine squared x, outside times outside, negative 2 cosine x, inside times inside, positive cosine x, last times last, negative 1. So if I combine these like terms, then I get that. So I have factored it correctly. When you have that 2 in front, it just kind of messes things up a little bit. Anyway, so that means that this piece has to equal negative 1/2, and this piece has to equal 1. Look up those x coordinates on the circle chart, and then pass your assignment forward. All right, good news. The stuff that we've been doing, I completely understand, has been pretty abstract, pretty out there, trying to change things into these things and solving these equations, all this other stuff. Way easier now, way more concrete, actually, like dealing with real triangles, okay? So today we're going to learn about the law of sines. The law of sines is used to find the missing sides and angles in triangles that are not right triangles, okay? It is so easy and it is so useful. Here it is. No, this is not sarcasm. What the law of sines tells us is that the sine of an angle divided by the length of the side opposite that angle is equal to the sine of another angle in the triangle divided by the length of the side opposite, which equals the length of another side of the triangle divided by the side opposite. So really all you have to understand to be able to use this is, first of all, Corey, all of the angles are uppercase letters, okay? And all of the sides are lowercase letters, and the sides are always across from their doppelganger, their friend, okay? So B is across from B, C is across from C, and A is across from A. And as long as you just remember that the angles are the uppercase letters, the capital letters, and the sides are the lowercase across from them, it's the easiest thing you'll ever do. What place did you finish in those competitions? Out of? A lot? Yeah. Were you nervous? Okay, so this is where the law of sines comes from. All right, so let's use this to solve a triangle where we know two of the angles and one of the sides. Okay? Are you ready? Don't blink, it's going to go quick. Okay? Here we go. To solve this triangle, I'm going to go the sine of 48 degrees divided by b equals the sine of 36 degrees divided by 8. The sine of this angle divided by the length of the opposite side is going to be equal to the sine of this angle divided by the length of the opposite side. Okay? And then all you have to do to solve that is cross multiply and divide, which means b equals 8 times the sine of 48 degrees divided by the sine of 36 degrees. Here are the two places that you can make mistakes when doing that on your calculator. First of all, what mode should you be in? Degrees, so make sure of that. Mostly we've been in radians up till now. The other thing that you need to be sure of is that when the calculator gives you that automatic parenthesis there at the end of the sign, you need to close that parentheses on the other side of the 48 or you'll get the wrong answer. Okay? So my advice to you is that all of you should do this on a calculator right now. It seems easy. How could I possibly make a mistake? But oh yes, mistakes are made frequently. You don't have to because it doesn't matter. But all of you should do this. Make sure that you're able to get the correct answer so that when you have to do this on a quiz or a test, you know with confidence that you've done it already. As soon as you got it done, tell me what you got. Not doing it. You're such a rebel. 10.11. We're trying to find this side right here. And Glory came up with 10.11. I feel like that's pretty good. The other side was 8. This angle that it's across from it is a little bit bigger. So that makes sense. Okay? All right, so now I need to find side C. But sadly, I don't know the angle across from side C, so how in the world am I supposed to do that? Not the Pythagorean theorem. Nice. Other Ben. Right, all the angles in a triangle add up to 180 degrees. So, yep, we could do it that way too. So 36 plus 48 is 84. So that means that this angle is 96 degrees. So to figure out side C, I'm going to go the sine of 96 divided by C equals. Technically here I have two different ratios that I could use. I could use the 8 and the 36, or I could use the 48 and the 10.11 that we just figured out. My advice to you is to always go back to the original information that you were given. So I'm going to set this equal to the sine of 36 divided by 8. Okay? So then side C equals 8 sine of 96 divided by sine of 36, which equals 13 point what? Okay. Thank you. All right, so we have solved this triangle because we have found all the missing pieces. We found angle C, we found side C, and we found side B. Okay? Do you love it or do you love it? It's way easier, right? Just a simple ratio. I like it. I love it. C equals 13.5. Oh, 8 times the sine of 96 divided by the sine of 36. Cole, that's just from this ratio right here. That times that divided by that. Okay? Okay, we can, nope. Nope. Tomorrow.